Hello everyone, wherever you are, I greet you and welcome you to our lesson. The topic is chemical equations. My name is Joseph Katenta. Here is the introduction. An equation is taken to be a sentence written to summarize a chemical reaction. It shows the reactants on the left-hand side and products on the right-hand side. So, look at this equation here which summarizes the reaction between iron and sulfur. When iron combines with sulfur, they form iron 2 sulfide. This kind of equation is called a word equation. But a chemical equation is even better because it gives us more information. For example, it expresses the reactants and products using symbols and formulae, but it also tells us how much of each reactant and how much of the product is formed. For example, here it tells us that we have one atom of sulfur combining with one atom of iron to form one molecule of iron 2 sulfide. The equation also tells us that iron is a solid, sulfur is a solid, and the product formed iron 2 sulfide is a solid. So from now on, you will be required to write chemical equations but not word equations. Here are the steps you will follow when you are writing chemical equations. Step 1. Write the formulae, all the symbols of the reactants on the left-hand side, and make sure that they are all correct. 2. Write the formulae and symbols of the products on the right-hand side and make sure that they are all written correctly. Don't forget to do some side work if you are to write the equation, the formulae of the products or some of the reactants. The side work will help you write correct formulae before you put them in your equation. Do not forget that diatomic elements, for example oxygen gas, nitrogen, chlorine, hydrogen, are written as molecules but not single atoms. So in your equations, when you're writing oxygen gas, don't forget to write it as O2 but not O, and so on and so forth. Step 3. Check if the equation you have written is balanced. That is, the number of atoms of each element on the reactant side should be equal to the number of atoms of the products of the atoms in the products on the other side. If the equation is not balanced, then you do the balancing by writing appropriate figures as multiplying factors in front of the appropriate formulae or symbols. Remember that any number that is written in front of a formula will be multiplying all the atoms in that formula by that number. For example, consider sodium carbonate, which is Na2CO3. This contains 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. But if we decide to put figure 2 in front of that formula in our equation, we mean that we have 2 times 2 atoms of sodium, we have 2 times 1 atom of carbon, and we have 2 times 3 atoms of oxygen. Step 4. Indicate the physical states of each substance in your equation using the following state symbols. If the substance is a solid, use S as a subscript. If the substance is gaseous, use G. If the substance is liquid, L. And if the substance is dissolved in water, use HU to mean that it is in aqueous solution. Here are some examples so that we can see that we can follow the rules. Example 1. Magnesium is combining with oxygen gas to form magnesium oxide. Our first step is to write the symbols and formulae of all the substances correctly. Magnesium, oxygen gas, and then magnesium oxide. Step 2, let's check if this equation is balanced. I can see that on the left we have 1 atom of magnesium and on the right it's 1 atom of magnesium. So magnesium is balanced. Oxygen. On the left, we have 2 atoms of oxygen, but on the right, there is 1 atom of oxygen. So we put a 2 in front of magnesium oxide to balance the oxygen. When we do that, we see that magnesium will also be having 2 atoms on the right. So we multiply magnesium metal on the left by 2, and our equation is balanced. Our last step is to put the state symbols. Magnesium is a solid, oxygen gas, then magnesium oxide is a white solid. Our equation is now good. Example 2 will be showing the reaction of iron metal with chlorine gas to form iron 3 chloride. Step 1, we write iron, Fe, chlorine gas is Cl2, then to form iron 3 chloride. Then we balance the equation. On the left we have 1 atom of iron, and on the right we have 1 atom of iron. Iron is balanced. Chlorine. On the left we have 2 atoms of chlorine, but on the right we have 3 atoms of chlorine. So if we multiply iron 2 chloride by 2, by putting figure 2 here, we shall have 2 times 3 atoms of chlorine, which is 6. To make sure that we have 6 atoms of chlorine on the left, we multiply this chlorine gas by 3. Chlorine is balanced, but iron is not, because we put a 2 here, and we have 2 atoms of iron on the left, on the right, sorry. So we multiply iron metal here by 2, and our equation will be balanced, just like you see it here. Next, state symbols. We know that iron is a solid, chlorine gas, I have the G, and iron 3 chloride is a solid. Let's go to the next example. Hydrogen reacting with oxygen gas to form water. Hydrogen is diatomic, H2. Oxygen gas is diatomic, O2. Forming water, the formula of water is H2O. Balancing the equation. We have 2 atoms of hydrogen on the left. We have 2 atoms of hydrogen on the right. So hydrogen is balanced. We have 2 atoms of oxygen on the left, but we have 1 atom of oxygen on the right. So we multiply water by 2 so that we have the oxygen balanced. But when we do that, we shall have hydrogen also multiplied by 2. So on the right, we have 2 times 2 atoms of hydrogen, that is 4. So we come to the left, multiply hydrogen gas by 2, and the equation will be balanced. Here we are. Steps. Hydrogen gas, oxygen gas, and we know that water is a colorless liquid. So this is the L. Our fourth example will be the reaction between potassium metal and fluorine gas to form potassium fluoride. Potassium, don't forget fluorine is diatomic, so F2. The formula of potassium fluoride is Kf, because remember the valence of potassium is 1 and the valence of fluorine is 1. To balance the equation, I have 1 atom of potassium on the left and 1 atom of potassium on the right. Potassium is balanced. Fluorine, I have 2 atoms on the left and I have 1 atom of fluorine on the right. To balance fluorine, I multiply potassium fluoride by 2 here. And I multiply potassium by 2 here. My equation is balanced. Now the states. Potassium metal is a solid. Fluorine gas, gaseous. Potassium fluoride is solid. How do we know it is solid? When a metal combines with a non-metal, the compound formed is ionic. Ionic compounds are, in most cases, solid at room temperature. Now you take this exercise and do it yourself. Let's have another set of examples of how to write the equations. Examples involving decomposition of one compound. Consider a compound like hydrogen peroxide. which can decompose to form water and oxygen gas. A decomposition reaction is that reaction in which a substance breaks down into simpler ones chemically. Now, hydrogen peroxide is H2O2, but it breaks down to form water, which is H2O, and oxygen gas. To balance the equation, let's start with hydrogen. Atoms of hydrogen on the left are 2. Atoms of hydrogen on the right are 2. Hydrogen is balanced. We go to oxygen. The atoms of oxygen on the left are 2. The atoms of oxygen on the right are 1 here and 2. 1 plus 2, 3. So we have 3 atoms of oxygen on the right. To make it easier to do the balancing, let's multiply water by 2 so that I have 2 oxygen atoms plus 2 oxygen atoms here. That's 4. On the left, to have 4 oxygen atoms, I multiply hydrogen peroxide by 2. 2 times 2, I'll have 4 oxygen atoms. Now, hydrogen. I have 2 times 2 hydrogen atoms, that's 4. Even here, on the right, we multiplied water by 2. So 2 times 2, we have 4 hydrogen atoms. This equation is balanced. Then we go to writing the state symbols. Hydrogen peroxide is dissolved in water, it's aqueous. Water formed is a liquid, oxygen gas, gaseous. Please try out number 2 and number 3. Now we get to another set of examples. This one is the set that involves a reaction in which a gas is displaced or another substance is displaced from its compound. 1. Zinc plus hydrochloric acid to form zinc chloride and hydrogen gas. Please try out number 1, number 2, and number 3 by yourself. Another example involves writing chemical equations for the reactions below. The first one shows zinc oxide reacting with calcium to form zinc and calcium oxide. Here are other examples for you to try out, and please take your time, write the symbols and formulae correctly before you fit them into your equation. There are enough examples for you to try out. Exercise 3. We have the formulae and symbols written for you, so you have one task, balancing the equation. And if you want more information about this, visit the links below so that you can learn more on our website. Thank you very much. Stay safe.